Hello guys, hope you are doing well. In this video, we are going to cover Docker essentials. As you know, Docker is an essential tool for us as an developer or an AI engineer. So let's begin. What is Docker? Docker is an containerization platform that allows you to package your code, libraries, and system settings into a single lightweight unit called a container. So, containerization, as the word suggests, that something related to container. So what we do, we package our libraries or our program that we have written into a container. We hold them inside a container. So that is what meant by containerization. And Docker is an containerization platform. Let's take an example. So, for example, we have an car. Okay, so there is a different components of car like engine, fuel, and the car software. But those all components are packed inside the car. Okay, they are not attached separately. They are packed inside a car. So that is what meant by Docker. We pack our all the software components, even the code, libraries, different versions into a container. So let's see why we need Docker. Uh, Imagine your project has multiple components. Like you are someone is doing front end, someone is working on back end, and something related to database and something related to AI. Okay, so these all persons have working with different libraries, working with different frameworks, and even working on different systems with different versions of tools or libraries. Okay, imagine uh, you have the Python version 3.11 audio system and you are working on it and you have built entire backend. But your teammate or your team lead have somehow different version like Python 3.13 or the latest version. So it will create problem when you run your backend in your lead or your teammate system, the system will goes down. Why? Because the version is not compatible. Okay, so that's where our Docker helps us. Docker helps us to package our versions, our code, and everything in a container, and then our lead or our teammate just have to run that container. He doesn't have to run the python main.py from terminal. He just have to run docker container file. Then he will see everything. He will see all the things that are really working on our system. Okay, he will see the same output that was we are seeing from our system. Let's see what will happen if we don't use docker. For example, team members is work have different versions of different languages or libraries, like I already said. So this thing will create conflicts between team members. Like if you have developed an complete system, but your leader is saying you have not developed, there are multiple errors. So to reduce those errors, to protect from those conflicts, we use Docker. Let's see what will happen then. If we don't use Docker, our deployment can fail because of OS or library mismatch. Like if we have different functions, different versions on our system, and the deployment requires different sort of version. Like if you have deployed anything to any deployment platform like Hostinger or Azure, you should know that there are multiple things that we have to keep in mind while developing a de- deployment ready application. Okay, so if we are not worried about this, we don't want to worry about this thing. We just want to build an application. We don't want to worry about what's deployment resources required. Okay, so that's where Docker help us. But if we don't use Docker, our deployment can fail on the OS from because of the operating system or library mismatches. And the last thing is manual setup takes time and causes errors. For example, I have different versions of different libraries or uh, programming languages on my system, and my team lead has different variants. So if the team lead sit down and try to solve the errors that are occurring because of the versions conflicts or because of the operating system mismatches, so that thing takes a lot of time and a lot of space on the lead lead system. So without Docker, this problem will also come. Let's see what will happen with Docker. Every team member and cloud environment runs the same setup. For example, if we have developed a complete system, then we have not to worry about what our team members and cloud will how take the system. We don't have to worry about the cloud different prerequisites. We don't have to worry about the team system. We don't have to worry about if the team has downloaded a Python, a different version, Python library, etc. Nothing. They just have to run that container Docker file. Okay, they just have to run the Docker file, and then everything will work. Let's see the major concepts in Docker. Obviously, Docker is helping us a lot and solving our bigger problem. So obviously there should be concepts or things that were inside it. So there are two major concepts inside Docker. First is Docker image and second is Docker container. This is the concept that creates difficulty in multiple persons. So let's break down it one by one. What is meant by Docker image? Docker image are the containers created from images. Okay, containers are created from images. But what is an image? It is a snapshot of your application and its environment like a blueprint. For example, if I want to build my new house, so what I will do first, I will first create a map of my house. So that is the same thing here. Before developing a container, we develop the container map, we develop the container image. So that is why it is called the snapshot of our application and environment or a blueprint. And what is a container? Container is a running instance of an image. Like the map is the blueprint of the house, but house is the itself is the practical thing. Okay, so container is that thing. Container is the real instance of the image. Image is just what how the container should look like, how the container will contain, etc. But container is the real thing. Okay, so uh, we will work with Docker images. We will write the code. We will use different sort of images from Docker Hub, but container is the main and actual thing that we need. Let's see what is meant by Docker Hub and Docker file. Docker file contains the instructions that tell Docker how to build an image. Okay, so we use YAML language to write a Docker file, as YAML is also a language that we use on multiple other purposes. So that is also useful in writing a Docker file. Inside Docker file, we write YAML instructions that tell Docker how to build an image, and Docker Hub is a repository. Like we have a GitHub where we store our projects, where we push our projects, we take the record, we build our profile. Docker Hub is a repository where developers can share their images, can install images from other developer providers, and can pull container images. Okay, so Docker Hub is has the same concept like GitHub, but here instead of code or instead of projects, we are pulling and forking the Docker images, okay, yeah, or container images. So volume is the persistent storage of our data in the Docker desktop. Docker desktop is a Docker application that we have to install on our system. Then we can use Docker properly. So inside that application, uh, there is a space or feature that is called volume where our actual data store. Let's see major concepts like Docker Compose network. Docker Compose, for example, we are working on a project where there are two components, front end and back end. And front end developer builds an image for front end, builds a Docker file or Docker image for front end, and the back end developer builds a Docker image or write a Docker file for back end. Okay, so they have built different containers for different components. So what if we want to just run a simple or just run wanted to run a one Docker Compose, because it is very essential Docker Compose for us, because if we are using free tiers of deployment platforms like Azure, we are using free tier of Azure, we cannot pull two images. Okay, we cannot push two containers to deploy on Azure. We must have to compose those containers inside a file, Docker file, and then push that file in the production. Okay, so that's where Docker Compose help us. That help us to compose two or more Docker files or containers or images inside a single file. Okay, that has written a tool to run multiple containers together. A network is a communication layer between containers. That is a background layer. We don't have to worry about it. Let's see the port working in Docker. As you all know, port refers to a communication endpoint that allows a containerized application to receive and send data over a network. That concept we mostly use in client server architecture or client server communication, or um, obviously when we run our application localhost, we see how the different ports are working, how we are using our application or 3.00 and the such things. So port refers to a communication endpoint that allows a containerized application to receive and send data over a network. Okay, as we previously see what is meant by network and what is the usage. As network is a communication layer between containers, so port help us to communicate or receive data or send data over a network. Okay, so there are different types of port that are working in Docker. First is host port, that is our computer port. This is the port on our host machine, like our machine, that is used to access the application running inside the container. It can be an open port on your system. That might create difficulty for you, because uh, let me understand you a concept first. Docker is a Linux-based application. Okay, Docker is not a Windows-based application that we just have to install Docker desktop and then everything work. works well? Nothing. Docker is a Linux-based application that can run on Windows by using virtualization. Okay, we use Docker on Windows through virtualization. We cannot use it directly. Okay, so for that thing, we have to done some steps that I will share you later on in any an other video. We have to go to some other tools and some utilize some other resources to install a proper Linux based environment on our system. So then then the Docker will be able to run our system. Okay, so that's why here different ports come. First, as I said, the host port means our own computer port, and the container port means the application port that is running inside the container. Our application port that is stored in the container. So our application have different port, our host have different port. So this is often a standard or uh, default port for this specific application, like 80 for a web server like nginx. So our host has a different port. Our contain application that is running inside the container have a different port. So the port mapping means the act of creating a network bridge. Okay, port mapping called as the act of creating a network bridge between a specific host port and a container port. Okay, the act of creating a bridge between host port and a container or application port is called port mapping. That might be asked by your manager inside your interview. So port mapping means creating a bridge between host and container port. So as I already said, for installing Docker, we have to done some some or maybe multiple steps on our system by using different sort of tools to make our system compatible for Docker. So let's see what is right here. You can use the standard Docker command line interface in Windows, but it is the Linux virtual machine that performs the core containerization operation using a Linux kernel. Okay, so it means that we can install Docker desktop. We can utilize Docker command line interface, Docker CLI, but we can't perform operations on containers. We can't make our we cannot containerize our application. We must have Linux kernel on our system to use Linux virtual machine that can help us to perform containerization operations on the Linux kernel. So there is a software that is used for it that is called Windows Subsystem for Linux WSL2. Uh, WSL2 is the modern recommended backend for Docker on Windows. So we have to install that system if we want to run Docker on our Windows. But that I am not going to share that step. I will share later in any video if you guys need it. By the way, we have covered the theory about Docker, what is meant by Docker, why we need it, if we don't use, what will happen, and the ports concept and other things. So if you really want to use Docker for your application, just write down in the comments. Then I will record an other video on how to install Docker on our Windows and how we can utilize it. So that's all for today. These things are related to installation. I will share the slides link in the description so you can also read out later. So that's all for today. If you guys have benefited from my video, just hit a like button and also write in the comments about if you really want to see the Docker installation, how to install Docker, or any other topics or concepts that you want to understand. So I will try my best. Thanks for listening me.